Hi, this is Paris, register number 40, and I will explain Kruskal's algorithm to find the minimum spanning tree from a given graph. First, we'll understand what a minimum spanning tree is. A minimum spanning tree, or MST, is a minimum cost subgraph of a given graph, wherein all the vertices are included and the number of edges are always one less than the number of vertices. That is, E is equal to V minus 1, where E is the number of edges and V is the number of vertices. Basically, if we take a look here, this if this is our given graph, 1, 2, and 3 are the vertices, we have to find a minimum spanning tree such that for these three edges there will be only for these three vertices there will be only two edges. And these two edges, which are of some weight, will add up to the least weight possible. Herein, we select the two uh, smallest edges and then just represent this graph as an MST. It is important to note that MSTs are always acyclic, that is, they do not form a cycle. MSTs are also never disconnected. So if you're given a graph here and a graph there and both are disconnected, no MST algorithm will work. You cannot find an MST. So we'll see what Kruskal's algorithm is. Kruskal's algorithm is a greedy algorithm used to find a minimum spanning tree for a connected or weighted graph. It makes locally optimal choices, adding lowest weight edges with the aim of achieving a globally optimal solution, minimum spanning tree, which is the greedy approach. Relatively simple to understand and implement, this algorithm is, and this algorithm is very easily representable also. We'll take a look at an example. If this is our given graph, we can see that there are five vertices A, B, C, D, and E. And these are the edges A and B with the weight 1, BC with the weight 3, CD with the weight 4, AC with the weight 7, AD with the weight 10, AE with the weight 5, and ED with the weight 2. We list them out here and then sort all the edges in the ascending order of their weights. We do the sorting so as to select the edge with the lowest weight possible to find a minimum spanning tree. After sorting, we get this order. First AB with weight 1, then DE with weight 2, then DC with weight 3, then CD with weight 4, AE with weight 5, AC with weight 7, and AD with weight 10. Since we can see that there are 5 vertices here, so for a minimum spanning tree, will automatically determine that the number of edges here we can take is 4. How Kruskal works is it starts by selecting the minimum edge possible, minimum weighted edge possible. So minimum weighted edge is AB. So we draw A and B. Next up, it selects the next larger edge, like the second smallest edge, that is ED with the weight 2. Similarly, then it goes on for the third smallest edge, which is BC with weight 3. Then it again in the fourth iteration, it goes for the other smaller branch, which is the smallest after these three, which is CD with weight 4. Kruskal's algorithm will automatically stop when we get the number of edges as less than the number of vertices, one less. It also stops or backtracks when cycle is being made. So for example, if AC had a weight 4, we could select AC also instead of CD. But what would happen is A, B, C would make a cycle. And this cycle is not acceptable in a minimum spanning tree. That is why Kruskal's algorithm is very efficient in finding an MST of a given graph with the minimum weights possible. So the sum of all weights in this graph is 1 in this MST is 1 plus 3 4 plus 4 8 plus 2 10. The time complexity of Kruskal's algorithm is O of n log n, where n is the number of edges. Thank you.